Okay, well, we've looked at some antiderivative properties for various types of functions, including things like exponential functions and logarithmic functions, power functions. What about now some trig functions? Well, as with any antiderivative rule, as soon as you find a derivative rule, there is a corresponding antiderivative rule. So on the left here, you will see a column of our basic derivative rules, and on the right you'll see a column of the corresponding antiderivative rules. So let's just kind of run over these really fast. The derivative of sine of u is cosine of u times the derivative of u. So the antiderivative of cosine u du is sine of u plus a constant. Derivative of cosine u is minus sine of u du. So the antiderivative of sine u is the opposite of cosine u du, cosine of u plus c. Of course, the derivative of plus c is 0. Derivative of cosine of u is sine of u minus sine of u, and that minus and this minus cancel out to become just positive sine of u. Derivative of tangent of u is secant square of u du over dx. So the antiderivative of secant square u is du is tangent of u plus c. The derivative of secant u is secant u tangent u times the derivative of u, which is so that means the antiderivative of secant u tangent u du is secant of u plus c. The derivative of cotangent of u is minus cosecant square of u du over dx. So the antiderivative of cosecant square of u du is minus cotangent of u plus c. Okay. The derivative of cosecant of u is minus cosecant of u cotangent of u du. So the integral or antiderivative of cosecant of u times cotangent of u du is the opposite of cosecant of u plus c. Here's a couple of hyperbolic ones. The derivative of sinh is cosh, so the antiderivative of cosh is sinh. And vice versa, the derivative of cosh is sinh, so the antiderivative of sinh is cosh. And how about a couple of inverse trig functions? Here are a couple of the most basic ones. The derivative of the arc sine of u, that is the inverse sine of u, is 1 over the square root of 1 minus u squared times du over dx. So the antiderivative of 1 over the square root of 1 minus u squared du is the arc sine of u plus c. You might see that in your calculator as sine with the superscript -1. The derivative of arctangent of u, the inverse tangent function, is 1 over u squared plus 1 du over dx. So the antiderivative of 1 over u squared plus 1 du is the arctangent of u plus c. Now you may notice there are some that are missing. For example, the derivative of secant is secant u is secant u tangent u du over dx, but we don't have just the antiderivative of secant u over here. It takes a little more work to do that. We may get to that a little bit later. But anyway, this gives us some basic ones. So any of these on the right-hand column then would be some basic things that we might be able to use. So we have a list here of about 7 problems, I guess. Some of these are finding a family of antiderivatives. Some are finding the exact value for a definite integral. Some are finding the exact formula for a specific antiderivative. Okay, so you got problems of all 3 major types. And you got some different functions. All of these, either in the problem or in the answer, are going to involve either a trig function or an inverse trig function. Okay, so I'm going to what I'd like to do now is we're going to actually stop this video here in just a second, and before we do that, if you would pause and write down these formulas, these problems. What I'd like you to do is go ahead and work through these problems on your own using the rules above and the techniques we've learned earlier, and you should be able to work these out now. Then come back and check your work against the solutions in the subsequent video. See you in the next video.